All right, cool. Hi everyone, I'm Rasmus from Karlstad Technique in Sweden, and this is me jumping straight into the presentation. I'm going to tell you about what Sigsum is and how we can use it for your application. So for short, Sigsum is a free and open source software project, and we provide a building block where you can discover which digital signatures are out there for what cryptographic signing keys. And the way that we approach this is by introducing a public append-only log for this building block. And basically what you get as a property here is transparent key usage. So every time you use your signing key, there's going to be a signature that's pushed into this log. Why is this an interesting problem to solve? So suppose you have one of these signing keys. My question to you is, how would you know if it has been compromised? So say the attacker has been able to somehow copy your key and then run away with it. Say they have, like, for a very brief moment, signing oracle access to your key. How would you know if they sign a malicious message and then they serve that to some user? Most likely you wouldn't know about this happening. And this is the problem that Sigsum is trying to solve. Which digital signatures are out there for what cryptographic public keys? The other thing that's interesting about Sigsum is that if we can start agreeing about what are the different signatures that are out there for different keys, we can also start talking about the data that you are signing things with. So it's the data as expected. So take, for example, a software developer, and you are signing some release. Now we can back up a claim like you're always going to put your signed binary on your GitHub release page, and it's always going to correspond to the Git tag. So you have those falsifiable claims, as Al was talking about, and you can now back it up because you know what are the messages out there that have been signed. So you have a concise history of this. So these are problems that Sigsum is solving. The project is funded by Mulvad VPN, and most of the development is led and done by Karlstad Technique, which is a sibling company that started around 2 years ago. Going even further back in history, Sigsum was part of the system transparency project. So this is something that Mulvad founded in 2019, and I remember when I met Frederick at a conference in 2019 in Stockholm, and he told me about how he wanted to basically prove to third parties what image is booting on a particular server. And one part of this design was to have a signature transparency log. And I remember for the first revision, then the idea was to piggyback on the existing certificate transparency infrastructure. And then I talked to Frederick. And then we agreed that it would be a much better idea to not do that and instead design a much neater log, which actually gets you a lot further and without any of the kind of hacking and piggybacking onto things. So we started out trying to develop this system transparency log together, Frederick and I, in 2020 in October. And I've been iterating for this for quite some time. So at some point we realized this building block is more interesting than just for system transparency. So then we rebranded this as Sigsum. And then as we've been iterating, we've been collaborating with a lot of different community members. Like we've been talking a lot with the Trust Fabric team, like Al and Martin. We've been talking a lot with Filippo, which is also a contributor of the project. And if I had to put out something which is I think interesting to look back on, is a bit how we've been navigating the design space for when you're designing a public log. And I think if you do design a public log, here are some of the design parameters that I think you would like to have some explicit choices on. And Sigsum has obviously some choices for these, and I'm going to get back to this table a bit later in the presentation. All right, so suppose you want to use Sigsum. Sounds great to know what is happening with your signing keys. Here is kind of the setting that we're trying to plug into. So we're going to assume that you already have some data and you want to be signing this data. We're going to assume that you already have a distribution mechanism for this. So you already have the way to get the data and the signature to the user. We're not solving data distribution for you. So maybe you're doing this on a GitHub release page, maybe you're doing this on a web server, whatever works for you. And we're also going to assume that the setting here, the user knows the public key. So we're also not going to solve a key distribution for you. So somehow the user is able to, run the right verification software with the right public key. If your setting looks like that, or if it could look like that, great. Sigsum could be a good fit for you. the attacker we have in mind here is one that is able to control this signer, so it can make any signature it wants. It can also control the distribution mechanism. So maybe they run the distribution mechanism, maybe they can do man-in-the-middle attacks. Pretty powerful attacker. The only limitation that we have is that the attacker is risk-averse. So they would really like to do this, tampering and signing, but if they get detected, it's like, nah. And this is like the typical transparency log setting where you want to detect things, and because you can detect them, you can also deter them from happening in the first place. So the goal here is simply we want to detect if the attacker is doing these malicious signatures, and hopefully that will cause some deterrence. So as an overview, we still have in the Sigsum system this signer and the user and this assumed distribution mechanism. We're introducing 3 additional parties. So one is, of course, the public append-only log. So this is basically an RFC 6962 Merkle tree, which you're all familiar with. And what it stores is signatures so that we can discover them. We're also introducing a monitor. So now we can enumerate this log and see for yourself what are the different signatures that are out there for different public keys. And then in order to solve this split view problem that Al was talking about earlier, and also actually to solve freshness for the monitor, we have another party called a witness. And this is going to help us out tremendously. And this is those C2SP specs that Al was talking about earlier. So let me talk about each of these parties in a little bit more detail. Before I do, security assumption. Threshold of those witnesses are of course, not compromised by the attacker, but the attacker is allowed to run some of them, and the attacker is allowed to run the log. All right, so looking at the user, suppose you're not using Sigsum, then this is kind of the setting where we're starting. You have a distribution mechanism, somehow you get the data, you get the signature, you verify it with the public key. This is all happening offline, so this is either gonna pass or it's gonna fail. If you add Sigsum, it looks almost identical actually. So you still have the distribution mechanism, the user. The only thing that changed here, instead of having a signature, we have a proof. And instead of having a public key, we have something called a trust policy. Now the public key and the signature actually haven't gone anywhere. So we're just going to have the signer's public key. It's going to be encoded in the trust policy. And the signature is going to be encoded in the proof. Then what we're also going to have in this trust policy is basically what is the identity of the logs in the system, what is the identity of the witnesses in the system, and how many of those witnesses are you going to require in order to consider this basically a secure system. And then for the proof, the signature is still in there, and then we have some other cryptographic details, which is going to convince you that this is a transparent signature. And my collaborator, Filippo, usually likes to call this a spicy signature. I will just stick with proof for now. I'm sorry. But yeah, so the property you get here, you had offline verification before, and you still have that after, and this is going to make it so much easier to integrate this with your application. So if you want to talk about why that is a nice thing to have, we can do that more in the breakout. But basically, reactive auditing and gossip is messy. Looking at the monitor, so great, we are now able to verify and enforce the logging. Now we also want to start detecting stuff. So without Sigsum, I put the sad face because we don't have a monitor. If you add Sigsum, then you can start enumerating this log and see for yourself what are the signatures that are out there for the public keys that you care about in your trust policy. And for this monitor to know that it's seeing the same signature that the users are accepting, it's also going to be configured with what are the logs in the system, what are the witnesses in the system, and then it's going to get this checkpoint that Al was talking about. And this is going to be basically the state of the log, and then those witnesses claims that this is actually an append-only log and it's fresh and you're seeing the same thing as everyone else. So this is what you get with Sigsum. You get to see all of those signatures. You can discover them and you can start doing something about it if it's an unwanted signature. So what you can also do with Sigsum is that you can start pulling the data if you know where it exists. So if you know that there's a claim that you're only signing binaries and you're putting them on your release space, now you can start putting the pieces together and see, well, are actually all of the signed binaries on the release page? Are they actually corresponding to these Git tags? And this is kind of how you can close the loop and start doing things where a third party can assess your claims rather than you just being able to know what happened with your public keys. All right, looking at the signer perspective here. So before, you could always sign something, and that's quite effortless. And this is part of the problem, right? Because if the attacker kind of takes your keys and runs with it, then it can start signing things. So here, some things ought to change a little bit. So what's going to happen is that when you want to sign something, you're going to sign a checksum, and you're going to put this signed checksum into the log. And then after a few API calls, you're going to get back this proof that we were talking about earlier, which is basically just the signature, and it's encoded as a proof, and you're also going to be convinced that it's a transparent signature. And then you can put this out on your distribution mechanism again, and it's similar to before. Instead of having the data and the signature, just put the data and the proof instead. And I want to emphasize here that this is a risk, and it's not for free. So what you're doing here is you're basically saying that, well, you do care about detecting what's happening with signatures that happens with your public key, but you're also going to depend now on the log being available when you want to submit here. So you have to kind of balance those two together before you start doing this, because otherwise you might find yourself not being able to sign. So there is a risk, but the reward is also really high if you do it. So if you want to submit something to the log, there's basically, again, RFC 6962 Merkle tree. And what we're storing in the leaf is a hash of the public key, a double hash of the data, and then there's the signer's signature on this double hash. And the reason why this is a nice thing to store as a log operator is because basically there's just two hashes and the signature, so you know that there's not going to be some funky, copyrighted metadata or illegal content making it into this log, which could be an availability concern because the log is append only. You can't take things down. So this makes it a bit easier to operate this log without being very worried about taking submissions from people that you don't really trust. So in order to get one of these leaves added, you can, as a signer, submit an add leaf request. And what you provide is the public key that you should use for the verification. You provide a hash of the data. So the log doesn't actually see the data, only a hash of it. So it's nice for performance, but also nice because then the log can't mint the data. And then there's the signature on this double hash. So what the log will do, it will compute the double hash. Now it knows it's a checksum, verify the signature, and then create the entry in the log. Then after some more additional HTTP API calls here, you're going to end up with this proof. And the proof is not that magic. It's still the signature that we had before. It's going to be an index in the log, so a leaf index. Then we're going to have like the nodes in order to do the inclusion proof. Then we're going to have this checkpoint again that Al was talking about. So for those not familiar, you can think of this as a signed tree head. So it's like a tree size, and it has a root hash, and it has a signature from the log. But it's also going to have those signatures from the witnesses, which are helping you claim that this is an append-only log and it's globally consistent. And the way that works, very briefly, so I'm not going to go into detail because we have plenty of talks on this later. But basically the log is going to, when it wants to create the next checkpoint, say to the witness that, hey, here's my next state and here's a consistency proof. And if the witness can verify it, it's going to say, well, looks good to me, it's append only, and then it's going to provide a co-signature back to the log, and then you can just put that into the checkpoint and start serving that to the users. What this co-signature means is that it's append only, or it's the largest append only log that the witness has seen at this particular time. And having the time here is very helpful for freshness for the monitor, and you can also start actually doing like time stamping of figuring out like when these things actually get logged, which is pretty cool. But yeah, I'm going to defer this to the later talk, so there's going to be plenty more witnessing things, and there's in very small the specs in C2SP if you want to click them later on the slides. So putting all of this together, on the right, we still have the signer, the user, and the distribution mechanism. The only thing that changed is that instead of having the signature, we now have the proof, and instead of having just a public key, we have a trust policy. We have the monitor in the middle, which is able to pull all of the signatures and be convinced that it's getting all of the signatures that this user is going to accept as valid, because it's failing closed on this trust policy. And then we have the witnesses here to solve the split view problems, and the witnesses to solve the freshness. And then, of course, the log, which is just storing those signed checksums. So coming back to this table, Anti-poison is this risk of, well, basically a poison log is the risk of getting some illegal content or copyrighted content into the log. And the way we solve this in Sigsum is to make sure that we don't have any arbitrary bytes in the log. You actually don't need them in order to achieve signature transparency. So we have 2 hashes, a signature, and that's it. For anti-spam, I didn't talk about it now, but we can basically make the user do a one-time DNS setup. And then you can rate limit on the domain name, or you can of course also rate limit on public keys if you want to. Sure, you can come up with plenty of other rate limit mechanisms, and those are not integrated in the log spec per se. They're optional parts that you can add on top of it, but that's the ones we have right now. For the API and the formats, we basically have some HTTP APIs and some well, data structures you can write by hand, like the checkpoint, for example. Very simple, very easy. Cryptography, we're quite opinionated, so we only use the SHA-256 and the ED25519. Might stand out at first. Reason why we didn't try to support all of these legacy options is because if we want to have this failed closed story, we ought to be able to update like the user software, for example. And then it doesn't make that much sense to try to support all of the different existing formats out there, because then we're going to be able to log a whole lot of stuff, but not be able to verify a whole lot of stuff. So that's why we went in this very narrow direction. The data structure, it's a chronological Merkle tree. We already covered that. When it comes to SCTs, so this is this promise of logging that you may or may not have heard of from CT. Short answer is we don't have them because we don't need them. Happy to talk more about that, but this goes back to this reactive auditing and the gossip, and yeah, that is just causing a lot of headaches also for the operations of the log, because you might make a mistake and then things disappear, which is not nice. Sharding, so it's this way of basically how do you shut down a log. So in CT you have temporal sharding, so once all the certificates have expired, you can just safely shut down the log. In Sigsum we have signatures. They don't expire in the same way, so it's not really applicable to do sharding, so we don't have that. The silver lining is that the verification for the user is offline, right? So even if we shut down the log and we want to rotate it, nothing actually breaks. So we can kind of do sharding, but we don't actually have it. So you still want to keep the things around for the monitors for some time, but maybe it becomes a tar file at some point in the future. Split use, we're using witness cosigning. Plenty of people are going to talk about it, so I'm not going to cover it. The only thing I'm going to notice is that we have basically a way to make the witness, even though it's listening for requests from the log, you don't have to run this on a public internet endpoint. So we have a way to basically hide the location of the witness, and this is great for reducing the attack surface. So since this is where trust is coming from, we want to make sure that it's as hard as possible to get in there and do bad things. And finally, we have the submitter privacy and the user privacy. So in terms of submissions, you can do you submit the hash of the data, and that's what you're leaking. And if we have rate limits on this, then of course if you provide the domain name and you validate the domain name, then you're leaking the domain name. But other than that, I think we've done a pretty good job of not leaking things to the log when you're submitting. And for the user privacy, nothing has changed. So whatever issues or non-issues you had before with your distribution mechanism, that's what you will have after as well. We have a getting started guide on Sigsum, and we're also going to have a birds of a feather session on Sigsum. So we're happy to talk about your use case, what you would like to use Sigsum for. If it's not working for you, then we would like to know why, so we can do it better. So a bunch of extra slides that I will show on the birds of the feather session later. So I'm just going to jump ahead to the end and say that the takeaway here is let's remember where we started. So we had this initial setting with a signer and assign some data. You already have a way to distribute this data, and then there's a way to sort of distribute those public keys to the software. So we're not solving data distribution, we're not solving key distribution, we're just helping you discover which digital signatures have been produced by what cryptographic signing keys. And this is what you get with Sigsum. You don't change the flows here for the user, so it's still offline verification, which makes it a lot easier to incorporate. You can still have the monitor now that discover the signatures, and optionally you can make those additional claims about where you're storing the data, what type of data is it, what can you falsify about this data. It's not something that we do per se in Sigsum, but you can do it with Sigsum if you want to. Some next steps. most important, we need to continue growing this witness ecosystem, and now we have basically interoperable specs, which is great. Now we also want to make sure that those specs run on production witnesses with good business continuity, because if we don't have that, then we have basically nothing, and we're back to the drawing board. So that's really important if we want to have a secure system. The other one is we're hoping to get some more independent Sigsum log operations. So this is an availability risk if it's just a single log, but if you have a few different independent logs, it makes it a lot less scary to actually start using this. We have a bit of a, as all projects, I guess, documentation backlog. We have a good getting started guide for like the key usage transparency, but if you want to start doing things with the claims and the data, it's basically in the heads of the people working in the project right now, so we need to flesh that out. Some hopes for the event. So I would like to talk a bit about how we configure witnesses, for example. So I've been noticing me and Al are sending a lot of emails back and forth lately with log public keys and witness public keys and different endpoints. And if we could find a way of like sharing configuration, I think that would make, well, our lives easier, which is great. And also as this system grows, it's not going to scale that well to send emails. And it can also reflect a little bit about, I mean, if we want to make a second version of Sigsum in some form in the future. So I mean, we are quite happy with a lot of the choices that we did in this table, but that said, there are always things that can be improved, and things have happened the past 4 years. So one example would be like the tiled APIs. If that would have existed 4 years ago, I would have selected that. Another user feedback is that even though ED25519 is great, sometimes you might want an IST curve, and it's not a bad choice. So maybe it should be slightly more permissive, even though we might not want to go all the way to like GPT signatures. Few other, minor things that you could consider changing. But yeah, if that is something someone's interested to discuss, I would be happy to. So with that said, that's my introduction to Sigsum and how you can use it. There's a bunch of links here. You'll find the Getting Started guide on the project site. You'll find some other information about the log that my company Karlstad is running. So we have a production log that you can use for logging. If you want to get an introduction to that, come to the Birds of the Feather session on Friday. All right, that's it.